We're going to take a look at whole numbers and numeration systems. So we start with the idea of what is a number, right? What do we mean by a number? And so the first set of numbers elementary school students study are whole numbers, and you can see that list above: 0, 1, 2, 3, 4, 5, 6, and so on. Right? That's the foundation of elementary school mathematics. But what do we mean by a whole number 3? A number is an idea or an abstraction, right? It represents some quantity, and the symbols we use to represent numbers, or those ideas of numbers, are what we call numerals, right? And so we use these numbers, especially whole numbers, right? There are 3 common uses for those numbers. They are what we call cardinal numbers when we're referring to quantity, how many elements in a set, in a finite set. Numbers, we would say, are ordinal numbers when they're used to describe order, right? You finish first, second, third. And then we also use numbers as identification, not as quantity, but as an identifier, like a name, right? It's just a symbol to represent some name. Like a number on a jersey would be an identification number. And so let's start with looking at the concept of a cardinal number. And so this idea of a student or a child counting, saying 1, 2, 3, just because they can count doesn't mean they understand what the whole number 3 is. And so what do we mean by that? There are 3 objects in the set. So the student or the child would know, if they understand counting, right, through a one-to-one correspondence, that each symbol, 1 represents 1 object, 2 represents 2 objects, 3 represents a total of 3. That 3 doesn't mean the 3rd object, right? In terms of cardinal numbers, 3 represents the amount. And so that's the idea of what we're talking about in terms of cardinality, or the cardinal number. How many objects are in a set? It represents quantity. Now that should lead us to this idea of how do we know one number is bigger than another number? And so ordering whole numbers is a concept students have to get a grasp of. How do they know that 2 is less than 5? Well, one way for sure is just looking at the sets, right? A set model. 2 objects is smaller than 5 objects, and formally we could say this is a proper subset, right? There's this one-to-one correspondence, but there's some left over. So 2 is a proper subset of 5, and so that means 2 is smaller than 5. And so we have this definition of how we know one number is less than another number, and it goes with this idea of the number of objects in a set, right? The number of objects in set A, the number of objects in set B. If the number of objects in one set is smaller than another, we say it's less than, right? Or we can say B is greater than. And so we have that language, and we have the symbols to describe that, right? And so we're looking at those symbols, and so you can now say 2 is less than 5. We have that symbol there to represent that, versus 5 is equivalent. The meaning, we just say it differently. 5 is greater than 2. And so how do we actually compare numbers again? One is through this set model that we can look to see how many objects are in one set compared to the other. You could also use a number line, right? Here is 2, here is 5, and we know that 2 is smaller than 5 because it's to the left of 5, or we know that it's closer to 0. So that's another way to check to see the ordering of numbers. And then another way students learn, or children learn, is through the counting. As you count 1, 2, 3, 4, 5, 6, 7, 8. We know 2 comes before 5, so 2 is smaller than 5. So that's, again, different ways to order numbers. And let's look at this official example. How do we determine if 3 is greater than, if 8, which number is greater, 3 or 8? Set notation here, right? Checking to see how many are in the set. Number line, looking at number line, 3 is closer to 0, or 3 is to the left of 8. And then you also can count, and then 3 comes before 8.